70 volt versus 8 ohm systems, or high impedance versus low impedance systems. Some questions to ask before the design to better understand your project and your client's needs and expectations. Speaker placement and sensitivity, loss of volume, how much amp power do you need, and distributed versus point source systems. So what is a 70 volt or high impedance system? It's a system that uses speakers designed for 100 volts, 70.7 volts, and 25 volts. Speakers have adjustable power taps, usually in 3 dB steps, and the amplifiers have high voltage, high impedance outputs that deliver constant voltage, so changing speaker loads does not affect speaker volumes connected on the same zone. Now, this is mainly used for distributed speaker systems that are comprised of many speakers. 8 ohm versus 70 volt. So an 8 ohm system, while providing the best fidelity and bass output, can be a more expensive system in the end. And you may need to calculate aggregate impedance of the speakers per channel to make sure they fall within the range of the amp. This often leads to complicated wiring because you need to have both a series and parallel connections to fall within the appropriate range the amp's looking for. You'll be limited in the total number of speakers per channel, and if different areas need to have different sound pressure levels, more than one amplifier will need to be used. Now, these systems are a better option for concert, house, worship, and arena settings. 70 volt systems can be cost-effective alternate to more expensive 8 ohm systems. There's simple wiring of loudspeakers because everything's wired in parallel. They can be easily expanded or downsized, and different areas can have differing sound pressure levels achieved while using a single amplifier. A 70 volt system is a better option for a distributed system. So a little bit about series and parallel connections. Here we have an example of 2 speakers rated at 8 ohms each connected in parallel. And we see how to calculate the overall impedance of this system because both speakers are rated at 8 ohms. You divide that impedance by the quantity of speakers. So 8 divided by 2 gives you an overall impedance of 4 ohms. Now those same 2 speakers connected in series, and how to calculate total impedance in the series connections. You take that 8 ohm impedance and you multiply it by the quantity of speakers this time to give you an overall impedance of 16 ohms. So as we said before, wiring a 70 volt system is much simpler because everything is connected in parallel. Here you have an example of that. 5 speakers rated at 5 watts each connected in parallel. So in a 70 volt system, the only limitation is wattage. And here you see the total of 5 watts. What are the advantages of using a high impedance system? Well, as we've mentioned a few times here, all speakers are connected in parallel, so there's no series wiring required. There's no need to maintain a specific impedance load to the amplifier, only a minimum load. And a failure of a speaker or an open speaker transformer won't cause the system to fail because they're all connected in parallel. Now there's a selection of power taps on the speakers that will allow for level adjustment in different areas to suit specific zone needs. Also, you can control volume by putting a simple wall attenuator in a speaker line. And as we've mentioned a couple times, adding and removing speakers does not affect volume levels on existing speakers, and longer speaker lines are possible with the appropriate wire gauge. So here we have an example of a simple 70 volt system where we have a background music source and a paging microphone going into a 70 volt mixer amp. And you can see here the lower 2 speakers have their volume controlled independently from the rest of the speakers using a wall attenuator. So some questions that should be asked before the design to give you a better idea of what your client's needs and expectations are, the type of system that they're looking to have designed. 1, where will the system be used? Will it be used indoors or outdoors? Do they need weather-resistant speakers? If it's an indoor space, is it highly reverberant? Do they need wide dispersion or narrow dispersion speakers? If it's indoors, what are the dimensions of the room? That's important for calculating Sound pressure levels, if you're trying to meet a specific level that's called for in the design. 2, what will the system be used for? Will this be a system used for background music, foreground music, paging, or signaling? And what are your client's expectations for quality of sound? Is their bass required as a club or restaurant setting? And if paging is going to be used, what level of intelligibility is expected? It can vary greatly depending on the project. For example, a retail space with paging versus, say, a hospital. 3, how loud will the system be, or how loud does it need to be? What is the ambient noise level in the space that the system is going into? Remember, we always try to be at least 10 dB over the ambient noise in the space. How will speakers be mounted? Will they be mounted in the ceiling? Will they be surface mount? Are there subwoofers used? Will these speakers be flown? All important information to get when you're selecting your equipment, the brackets you'll be using to mount your speakers and whatnot. What will speaker spacing be? So this can depend on the SPL coverage that is called for in the design, the expectations of the customer, perhaps code you have to meet for the design. 6, what amplifier power and wiring is required? Well, that will depend on the number of speakers in the design and the power going down the line to these speakers. Of course, a larger number of speakers and more power on the line means a larger wire gauge will be needed. Do we require signal processing? Will you be needing to EQ anything in this design? Will you need muting capabilities when you're distributing background music during paging? Will you want to put any compression or limiting on your system to prevent the end user from damaging equipment once they get their hands on it? 8, do we need multiple amplifier zones? Will this system be delivering different sound sources to different areas? For example, in a restaurant, maybe they want the bar area to be fed from the satellite TV feed. The dining room, they want a different sound source, a little more low-key music perhaps. Maybe out on the patio they want something a little more upbeat, something you'll have to find out from your client. Number 9, what type of sound sources are required? Will there be microphones for paging? Maybe there's telephone paging. You'll have to get the appropriate modules for that if you're using the 9000 series. What music sources will there be? Will there be music sources? Are they using CD, DVD, MP3 music services? Is there a need to provide pre-recorded digital messaging in case of an emergency situation? Or do you need tone modules for alert signaling, something like shift changes on a factory floor? Or bells to indicate class changes at a school? Do you need to have the ability to mute background music sources while paging? Or do you need to allow for a fire alarm panel to take priority over your audio system should the worst happen? 10, what type of system will you be using? A high impedance or a low impedance system? Now, generally low impedance systems are used for performance foreground systems in, say, concert halls, auditoriums, houses of worship, arenas, and so on. They require heavier gauge wire and care in final speaker impedance. As we've mentioned a few times, the wiring layout can be more complicated because of the need to mix series and parallel connections to maintain a constant impedance. Constant and minimum impedance must be maintained, as we've said, by using those connections. High impedance systems are suitable for multi-zone paging and background music distribution. The wire gauges are usually smaller and the wiring layouts are much simpler. As we've said, it's all done with parallel connections. Now there's easy volume control using wall attenuators or simply the power taps on the speakers themselves. Designing the system. So going a little bit into sound pressure level. Now sound pressure levels are expressed in decibels or dBs. And typical dB levels are expressed from 0 dB to 140 dB, which is the threshold of human hearing to the point at which permanent hearing damage occurs. Now, some reference examples for you. 30 dB is equivalent to a soft whisper at 5 feet. 50 dB is your typical private business office. 70 dB is the average male voice in conversation. 90 dB truck traffic, and 115 dB is your typical rock concert. Now, it's important to keep in mind that the average listener can just hear a 3 dB change in volume levels, and they perceive the volume levels to have doubled when there's an increase of 10 dB. Speaker sensitivity. Now, this indicates the efficiency of a speaker. Manufacturers measure the speaker on axis at 1 meter distance by applying a 1 watt complex signal. Now, this is referred to as the 1 watt 1 meter specification under sensitivity. Now, higher sensitivity is more desirable as it means the speaker is more efficient. How much power to increase the volume levels? Well, for every doubling of power, there is a 3 dB increase in volume. So if we look at our example here of a speaker has a sensitivity of 90 dB at 1 watt 1 meter, if we were to increase the power to 2 watts at 1 meter, we would be looking at 93 dB. 4 watts at 1 meter, 96 dB. 8 watts at 1 meter, you'd be hearing 99 dB. Loss of volume over distance. Now, as we move away from a speaker, we hear that the sound level decreases, obviously, but by how much? Well, for every doubling of distance, you have a decrease of 6 decibels. So going back to that same example of 90 dB at 1 watt 1 meter sensitivity, if we were to increase our distance to 2 meters, you'd be hearing 84 dB. Increase that again to 4 meters, you'd be getting 78 dB. And increase it again to 8 meters, you'd be hearing 72 dB. So why is this important? Well, we can use these simple constants to make quick on-axis calculations of how loud the volume will be in decibels when the speaker is at a particular distance and the amplifier is providing a certain wattage. So a simple example here, using that same speaker, 90 dB, 1 watt 1 meter sensitivity. It's being used in a design that calls for 84 dB at ear level. Now, since this is a ceiling speaker, ear level will be 4 meters away from that speaker. So you would be hearing 78 dB with 1 watt applied to it. So to meet that 84 dB that the design calls for, we'll be tapping that speaker at 5 watts. So what happens off axis? Well, we saw that sound pressure levels decrease as we move away from a speaker. Now, the same thing happens as we move off axis from the speaker. So manufacturers define coverage angles based on when the speaker levels off axis drop by 6 dB from the on-axis response. So suppose the coverage specification for a speaker was 60 degrees horizontal at 2,000 hertz. Well, this means that the off-axis volumes are down 6 dB, 30 degrees to each side of the on-axis response on the horizontal plane. So this is important because knowing the off-axis response of the speaker and the amount of even coverage required for the application or project will determine how many speakers you'll be using and what the spacing of those speakers will be. Obviously, the smaller the spacing between speakers, the more even sound levels you'll have between speakers. Now, you can see here an example of how that's used when putting in paging horns, determining the angle at which you'll have them pointing down. It all depends on that off-axis response. Now, how much amplifier power do I need? Well, as we said before, it depends on the number of speakers and what those speakers are tapped at. So if we were to take an example of a project that required 19 speakers, and if we were tapping those speakers at 5 watts each, that would give us a total required wattage of 95. Because we like to leave headroom, about 20%, to account for peaks in the audio signal, we would be looking at 114 watts required from the amplifier. So we would select a 120 watt amplifier to account for that. Room setup. So someone comes to you and says they need a quote on an audio system in a room that is 50 feet wide by 100 feet long. Well, you have to ask them, what will this room be used for? Will it be used for background music? Do you simply need ceiling speakers? Will it be used for foreground music? Will you have wall-mounted speakers? How high of an impact do they need? Perhaps the room is being used as a presentation space and you just need to simply reproduce computer sounds. Maybe it's going to be a theater-type setting and they need theater-style impact. Or they just need paging in this room and they need to reproduce the human voice. Or maybe there's going to be a live band and they need full frequency response from their system. Well, their answer to this question could determine whether they were going to be using point source or a distributed system. Now, why would they use point source? Well, maybe the ceiling is too high in this space, or the ceiling is simply not suitable for putting speakers in, or perhaps they're trying to draw attention laterally for presentations. Now, some cons of a point source system: it could be too loud if you're too close to where the speakers are mounted, and it could have a minimal throw distance. So a distributed system. Pros of a distributed system are there's even coverage. It's a non-obtrusive look. The size of the room is not a factor, and there's an ease of wiring during roughing. Some cons will be that you could be limited to size, and ceiling material might restrain certain installs. Now, here we have a couple resources for you if you're looking to get help from TOA for your design. We have a couple design worksheets that you can fill out to give us a better idea of what your client's needs or expectations are for their project. So we encourage you to go online and fill those out if you're coming to us for help. We also encourage you to take a look at our speaker placement viewer. It's a software that we have you can find on our website that you can use to get some visual representations of how our speakers will behave in a space that you need to put your project into. All kinds of parameters that you can play with to get a visual representation of what the sound pressure levels will be in that space. What type of wiring for the speakers? Well, as we've said, it depends on how many speakers are in the system and how much power will be going down the line. Of course, more speakers, more power means a higher gauge wire. Now, in our example that we have here, we see that 100 watts must be delivered to all the speakers in one zone. Now, the total distance of that run is 720 feet. So going through the chart here, we can see that we would need to use 16 as our wire gauge. Now, some more resources that you can find on the TOA Canada website: our speaker guide as well as our amplifier guide to look up all the specifications on our products, to get an idea of which ones would fit best for your design. And here we have some pretty pictures of both high impedance and low impedance amplifiers offered by TOA. Our BG series, 9000 series, our wall amplifiers, our DA series, as well as some pretty pictures of the wide array of speakers that TOA offers, from in-ceiling speakers to box speakers, weatherproof line arrays, pendant speakers, whatever application you need, we can provide a speaker for that.